Um, Hello everyone. So I forgot to record my like screencast yesterday because I don't know, I got a bit late. Uh, so I have now thought of releasing the solutions. Anyways, I was able to do up till D and just now I've solved E as well. And I was hoping that today is actually code chef, so I was planning on giving that, but it's tomorrow. Yeah, so let's discuss my approach and the problems. Also, I felt the last tutorial that I had released was a bit short, like it was just 15 minutes. So I'm trying to make it at least 30 minutes. Okay. So the first problem stated that Rudolph is going to visit Bernard and he decided to take the metro to get to him. The ticket can be purchased at a machine that accepts only 2 coins, some of which does not exceed K. Rudolph has two pockets with coins. In the left pocket, he has n coins with denominations this, and in the right pocket, there are m coins with denominations these. He wants to choose exactly one coin from each packet such that this total sum is less than equals to k. And okay, so let's say he has some collection of coins 1, 2, 8, 10, and here he has some collection of coins like 3, 5, 6, and 7. Now he wants to choose one coin from this and one coin from this. Let's say this is x, this is y. Now x plus y must be less than equals to k. And the constraints are also like n is 100 and m is also 100. So this becomes pretty forward that n into m of n into m will pass here. So what you could do is just iterate through all the loops from 1 to n all values, and inside those, for each value of n you could go to all possible values of m, add them, and check if it is less than equals to k. And yeah, since the constraints are so less, we can do this. Other possible approaches would be some sort of binary search, but I am not going to that because this is div2a, div3a, and it's like, according to me, this problem would be like 400 rated because it is very direct implementation. Let me show you my solution now. Um, yeah, I just took the input A, input B, and then I declared a answer variable, and then I iterated through all the values for a of I and b of j, and checked if a of I plus b of j is less than equals to k. If it is true, then answer plus plus, and finally see out the answer. Okay. Also, I forgot to tell you that I'm now finally a pupil. Yeah, like finally I've reached pupil again after how long? Okay. So I had become a newbie in November 2023. Then I started giving contest, and now finally after 4 months, I'm 5 months. Now again a pupil. So feels good. I think Priyansh's sheet has helped me a lot because I was able to figure out the solution to some of the problems very quickly. Even while I didn't actively know the solution, I was typing and I got the intuition. So this problem is a bit harder. It was a bit harder as compared to like C or D even, because um, although it is a very direct problem, the greedy approach was quite tough to actually think. So basically, you are given an array in which you can perform only these operations, like a of I will be decreased by ones, a of I minus, you can decrease a of I by 2, and then a of I plus 1 also by 1. So and you want to make all of these 0. So the only okay, so let me look at the test cases and then see if you can find out the solution to it. 552. Now I can decrease this once, this has to be decreased twice, this has to be decreased once. So this becomes 1, 4, 5. Now again this once, 2, and 1. So this becomes 2, 4, 2. Now I will decrease this by once, this 2, this 1, and again 1, 2, 1. So this is 0, 0, 0, and all are 0. Okay. Let's look at another test case. This is 2, 4, 4, 5, 1. So I have to make this element 0, right? So I'll decrease it 1 and decrease this by 1 again. So so basically this becomes 0, this becomes 0, this becomes 2, this becomes 5, this becomes 1. Now I'll be decreasing this by again by 2 times, this will be decreased 4 times, and this will decrease 2 times. So now this becomes 0, 1 and minus 1. Now I will decrease. Now there is no possible way then I can decrease this or increase this, right? So that means that it is not possible. All right. Now in the second test case, it was 0, 1, 3, 3, 1. I cannot decrease this, so I move forward. I can decrease this by 1, decrease this by twice, decrease by 1, so this becomes 1, 2, 1, and 1, 2, 1. Now answer is 0. So basically, there was a pattern which I had found out, that in order to make all of these elements 0, I have to make ai minus 1 first 0. So if I'm given like a1, a2 up till an, then a2 will be decreased by a1 number of times, and a3 will be decreased by a2 will be decreased by twice of a1 number of times, and a3 will decrease by twice just a1 number of times. If at any value I see that my ai becomes 0, then answer is no. Otherwise, after I have done everything, I will check if it is possible that my the value which I am getting, if all the values in my array stored after applying these operations are 0, then answer is like yes. Otherwise, the answer is no. So yeah, my implementation also speaks for itself, that the code that I have just said. Hmm. I got a wrong on test case too, because of this condition. This must be done after I have, like, after I have done this operation, not before. That is why I was getting a wrong answer, because it is not checking for the nth element. Alright, yeah. So the right implementation is, yeah, you just decrease, you just see if AR of I is equal to 0, then continue. If AR of I minus 1 is less than 0, then answer is obviously no. Then you move forward and decrease I by twice of AR of I minus 1, and ai of I plus 1 by ai of I minus 1, and make ai of I is minus 1 is equals to 0. Alright. And now in this I have just counted the number of zeros that is present in my array. If it is equals to n, that means all of the elements are equal to 0, then answer is yes, otherwise answer is no. Alright. Okay, cool. So Rudolph has a string of length n, and he wants, and Rudolph considers the string ugly if it contains the substring pi or map. Alright, or both. Okay, so if it contains a substring pi or substring map, otherwise the string will be considered beautiful. For example, PPI, MMAP, and a map are ugly substrings, while math, PPI are beautiful substrings. He wants to shorten the string by removing some characters to make it beautiful, but he wants to remove, he can remove characters from any positions, but he wants to remove the minimum number of characters. So the thing is, it is always possible to make the string beautiful. Why? Let's say you have map, alright. Then you can just remove all characters, so answer is n, alright. But he wants to do the minimum operation. So let's say if you have like map, then you can just remove any one of these characters, and the string will be beautiful, alright. So let's say the first is MMAPNAPIE. So here map is present, so you just have to remove any of one of these characters. Like you could remove M, A, or P. Most probably, like, the thing is, if you I cannot decide which character I have to remove, because it can happen that after remove M, one M is already present here. So now I have to remove two characters if I'm basically focusing on M. But if it is in a continuation of A's, then if I remove A, then it becomes another possibilities. So if it is like this, is M A A P P P P. So this is, obviously it is always optimal to remove A, because it is the only character which is actually forming the letter map. Alright. Then you have something same for pi. So for pi, obviously you would have to remove I only. Alright. Cool. So obviously the answer will be, let me show you a bit common examples. So you have map, 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 and map. All right. So you remove a from here, a from here, a from here, and a from here. So answer is 4. Also, you can see that 4 is actually the equals to the number of occurrences of map in this substring. All right. Basically, same will happen for pi. All right. You have to remove I everywhere. I from each occurrence. So now the answer is 4, which is also equals to the number of pi's. Okay. But there is a twist. What if you get something which is a map I? All right. It is possible to get a map I in the substring. Right. Now if you have a map I and another map I. Okay. So you get a map, so you remove A. You get a pi, you remove I. Map, you remove A. I, you remove I. Okay. So the answer that you're getting is 4. Okay. But we can actually make it beautiful substring just by removing P. Alright. Then my string will be MAI and MAI. And this is a beautiful substring. Okay. So I think now you could see the pattern. It is actually equals to the number of occurrences of map, number of pi minus number of mapi. All right. And yeah, that is the implementation part. And let me show you the code now. Also, I need to like understand how to do substrings operation. I get a wrong answer in most of the cases. Yeah. So basically, I did it from 1 till n minus 3, counted the number of occurrences of map here. Then also in the same loop, I counted the occurrence of pi because they have the same length. And then I formulated another loop in which I calculated the number of map I. Alright. That is stored in count 3 and the maps is stored in count 1 and then count 2. And finally, the answer is count 1 plus count 2 minus count 3. Okay. Yeah, it was very basic. And I think this problem is 900 or I think it's 800 rated. Cool. Okay. Mm, Now we go to problem D. So problem D was basically Rudolph and Bernard are another tip that I want to give you is nowadays since I have been solving so many problems, I practice one technique which is known as passive reading. I don't read the entire problem. I mostly try to figure out the problem by reading the few statements, and then I also see the like constraints. Okay, and then I start to formulate a solution to the problem. Okay, so basically, Ron and Bernard decide to play a game with friends, and people stand in a circle and start throwing a ball to each other. They are numbered from 1 to n, the clockwise order. It's called a transition movement of the ball from one player to his neighbor. The transition can be made clockwise or counterclockwise. Okay, and it's called the clockwise pattern with the number of transitions that is needed from to move from player y1 to y2. For example, if it is, I think, let me explain you the problem. Uh, this would make it simpler. Let's say you have like some friends 1, 2, 3, 4, 5, 6, 7, and now one person has the ball in the beginning. He can now throw the ball. Let's say throws it to some two distance in the clockwise direction. So now 1, 2, and now 3. So 4 has the ball. Sorry, 3 has the ball now because 1, 2, and then 3. Okay. Let's say if he throws in counterclockwise direction, then 6 has the ball. Okay. Now, yeah, that's it. And now the question stated that Rudolph actually forgot it that where the person is throwing the ball. He just remembered that this is some distance and remembered that it might be clockwise, might be counterclockwise, or might be either. Okay, so now you have to calculate the number of occurrences of people who can actually have the ball in the last. Okay, so you start from like 1, 2, 3, 4, 5, 6. So in this case, let's say he threw some two distance. Also, it was difficult to maintain. Okay, so let me explain to you a bit of modular arithmetic. Let's say he throws one. I say that he has thrown up to a distance of 8. All right. So 8 would be 1, 2, 3, 4, 5, 6, 7, 8. All right. So now this is nothing but 1 plus 8 mod 6, which is 9 mod 6 is 3. Cool. And let's say, okay. And it can work in subtraction as well. So if he says that I'm at 1 and I have to throw in 2, let's say 3 in counterclockwise. So see, it becomes 1, 2, 3. So 1 minus 3 plus 6 mod 6. So this is 6 plus 2, 8 mod 6. Just wait. 1, 2, 3. 1 minus 3 is, okay, sorry. This minus 2 and then 4 mod 6 is, yeah, 4. Okay. So this is how modular arithmetic works. Now actually I've started to implement it using a zero based indexing instead of a one based indexing. Makes the modular part very clear. So 0 is the 1 and let's just decrease all of them by 1. Okay. Now let's look at the first case. He's saying that I threw 2. I don't know which direction. So it could be like 0, 1, 2. Okay. 0 से 2 पे चला गया. हो सकता है 0 से पीछे चला गया तो अब कहाँ चला गया 0 से 4 पे. ठीक है. उसके बाद उसने बोला 2 वापस से कहीं चला गया. तो 2 हो सकता है 4 को फेंक दे या फिर काउंटर ब्लॉक में तो 0 को फेंक देगा. फिर उसी तरह से 4 हो सकता है कि 6 को फेंक दे या फिर हो सकता है वापस चले 2 आ गया. ठीक है. तो अब पॉसिबल इंडिसेस क्या होगा मेरे पास 0, 2, 4 and 6. Also 0 and 6 is same. It is equals to 0 only. Okay, later I will change it. Okay, 0 to 4 ये पॉसिबल हो गया. उसके बाद उन्होंने बोला कि आप 0 भी 2 फेंक सकते हैं और 2 भी 4 भी. ठीक है. तो ऐसे करते करते एक तुम देख रहे हो कि बाइनरी ट्री टाइप का बन रहा है कि तुम ऐसे स्टेट्स बनती जा रही हैं. ठीक है. ओके. बट आई एक्चुअली डू नॉट केयर अबाउट लेट्स से you saw that I'm now forming a tree sort of structure, right, which also has some repetitive values. All right. I actually do not care about this portion. Okay, I only care about the parent portion and the children and the final state. That is all I care about. So I don't have to remember this. Okay. So अगर तुम सोच रहे हो कि रिकर्जन से कर लेते हैं तो रिकर्जन से तुम प्रीवियस ट्रेड्स को स्टोर करते रहोगे जिससे टाइम कॉम्प्लेक्सिटी को कभी सेटिस्फाई नहीं होगी. इसलिए रिकर्जन नहीं करना है. ठीक है. क्या करना है देखो तुम बस एक काम करो तुम एक सेट बना लो और उसमें तुम ये चीज़ें डालते हो जैसे कि ये वाला एग्जांपल लेते हैं 531 531. Okay, 3 is the number of queries and 1 is the starting person. Okay, I think yeah, X is the starting person. Okay, so now you're like to 5 and 0, 1, 2, 3, 4. 0 is nothing but 4, 5 only. Okay, so he's saying उसने 0 का मतलब होता है कि क्लॉकवाइज क्लॉक है शायद ऐसे चलती है तो हाँ तो 0 से 4. सो 1, 2, 3, 4 4 को आ गया. ओके. उसके बाद में 4 मैंने बोला कि आई डोंट नो वेयर एम आई थ्रोइंग दिस. इट कुड बी क्लॉकवाइज और कुड बी एंटी क्लॉकवाइज. 1, 2, 3, 4. ओके. सो 3 or it could be 0. All right. After that, he's like, I threw one distance, I don't know where. So this could be 4 or 2, or this could be 1 or 4. All right. So the possible answer becomes 2, 3, and 4. All right. All right. That is all that you have to do now in the implementation part. You create a parent set which is initially having just the value, which is in this case, what is the value? It is 1 or some x. This is the value which is contained, and then keep on doing this. and just swap, create another set for the second transition and keep on swapping them. All right, that's it. Since the time constraints are like less than 1000, you can swap the sets. Swapping the sets actually takes place in order of one time if you don't know. Yeah, let me show you. Uh, Time complexity to swap two sets. Mm, Actually, even swapping is a routine, yeah? Constant. Yeah, you can see it takes place in constant number of time. Cool. Okay, so that means this could have been worked for some other test cases as well. But the problem is that it can only be verified in n square or some n square n into m square, right? That is why it is needed. Cool. Let me just show you the code. See, I took in the input and then I created a set st. In the st, I first inputted x. X is nothing but the number which is the starting position. It could be anything. Okay. Now, if ch is equals to now I'm taking the reading the queries. So I'm taking an int a vector which means the distance. Char ch means the direction in which I'm flowing. It could be question mark 0 or a 1. So if it is a, now I've created another set temp. The thing is that I cannot do this. Uh, I think many of you might be thinking, wait, let me just explain, and then I will. I think that I know the doubt which you guys might have. Now I just went to set and in added the value for each element by the distance and took the modulo n because it must remain in that range only. Took the same for subtracting it as well as I do it in anti-clockwise direction. Okay. Now if it is 1 then I have thrown it in clockwise direction. So just subtract it. Otherwise just add it. Okay. And also take the modulo n. Now I'm just printing st here for like seeing if there was some error in the code. Then I cleared st and put all the value of temp into st. Okay. I think this operation takes order of m time of m log yeah m time. But no, this is also constant. Yeah, this is constant. Now I have to print the size of st, which means the possible values which uh, might be present after the game has ended. And the thing is, if it is equals 0, I have to push print n, right? But also the value have to be printed in sorted order. So what I did was stored all of them in a vector and then printed that vector. Okay. Now I think I know the doubt which you might have. Like, why am I keeping a track of another vector? Like, I could very easily do this. No? I should insert whatever the previous value was and then insert it. The thing is that this is an infinite loop. Why? Let me show you. That let's say you have 1, 2, 3, and let's say 2 distance previously. So you insert 1 plus 2 mod something, and now this value gets inserted into a set. So you are constantly picking up some value and inserting it. All right. So this becomes a cycle and an infinite loop. That is why I needed another set, which is temp. All right. Yeah. As far as the difficulty of problem, this is almost a 1208 problem. Okay. Yeah. Now moving on to a problem I really enjoyed like up solving. The okay, so the problem is pretty simple. All you need to do, I think, not in terms of like implementation, in terms of the understandability of the problem, it's simple. All you need to do is just make a bridge from this zero till this zero, and you need to make k bridges, and you need to install some supports on this as well. So this is 0 and this is 0 and this is some 1 2 3 4 5 6. Okay, so this means that a pillar of 2 has to be inserted, a pillar of 3, a pillar of 4, a pillar of 5. Okay, like this a bridge has to be formed. Okay, now the thing is that the cost of installing a um, support is a of I comma a of j plus 1. A of I comma j actually denotes the depth of the uh, with f. Okay, okay. So yeah, basically this is just okay. So this is 0 1 2 3 4 5 4 and then 4 3 2 1 and 0. Now you need to plant supports which are having distance uh, 4 between them, and you just need to plant one bridge. Okay, so if I solve it for one, then it is basically just a loop for all of the others, and then I can get the answer. So let's say 0 1 2 3 4 5 4 3 2 1 0. Okay, now a bridge, the initial point of the bridge must be here, the ending point must be here. In between I have to decide where I need to plant the support. Okay, so let's say I move forward, right? So for, is it necessary to plant a bridge here? Cool. So I think yeah. So that means that for the best approach would be कि मैं देखूं कि इसका मिनिमम डिस्टेंस वाला पॉइंट कहाँ पे है जो कि एक्चुअली में डी डिस्टेंस से कम पे है, ठीक है? ओके, सो लाइक वन के लिए क्या होगा कि पहले सपोर्ट जीरो पे इंस्टॉल करूँ, राइट? यहाँ यहाँ पे ना करूँ, ठीक है? देन आई मूव फॉरवर्ड और चार डिस्टेंस पे देखना है। तो टू के लिए क्या होगा कि टू के लिए मैं फिर से जीरो पे इंस्टॉल करूँ, यहाँ पे ना करूँ। लेकिन अगर यहाँ पे इंस्टॉल करूँ इसकी वैल्यू क्या होगी? ये हो जाएगी टू प्लस वन and plus 1 which is 4. Okay, and then for 3 it will be 3 plus 1 plus 1, right? Because इसके minimum distance अभी भी 0 पे ही है. Okay, so this is again 5, and then similarly I can just keep on moving forward and just trying to see कि कहाँ पे actually best होगा option. As soon as like एक मैं मल्टी सेट में डाल रहा हूँ ना ये सारी वैल्यूज को, तो जैसे मेरे सेट का साइज डी डिस्टेंस से बड़ा हो जाएगा, all I need to do is I need to keep on removing the first element. दिस इज इवेंचुअली सेम एज कि तुम पहले डी डिस्टेंस से कुछ रिमूव नहीं कर रहे, उसके बाद ये फर्स्ट एलिमेंट को रिमूव करते जा रहे हो एंड देन यू आर फॉर्मिंग अ न्यू डीपी. ओके, सो न्यू डीपी की वैल्यू हमेशा हो जाएगी सेट के बिगिनिंग एलिमेंट से. आफ्टर डिस्टेंस 4 ये 0 हट जाएगा, तो अब कितना हो जाएगा 1, और 1 पे वैल्यू कितनी होगी? वो होगी 2, क्योंकि अब एक सेट यहाँ पे इंसर्ट कर चुका हूँ. इसकी वैल्यू जाएगी 3, ठीक है? तो डीपी ऑफ 4 की वैल्यू जाएगी 4 प्लस 1 प्लस 3 विच इज 8. कूल. नाउ 5 की वैल्यू जाएगी 5 प्लस 1 प्लस 3 विच इज 9. ऑलराइट, हमेशा 3 पे कुछ वैल्यू जाएगी, 2 पे, 1 पे, 0 पे. ओके, और फाइनली मैं देखूंगा कि डीपी ऑफ एम पे वैल्यू क्या हो रही है. डीपी ऑफ एम पे वैल्यू इससे मुझे मिनिमम मिल जाएगी, ठीक है? ओके, एंड या, और उसके बाद मुझे क्या करना है कि मुझे कंसेक्यूटिव ब्रिजेस बनाने हैं ना, तो मैं एक काम करूँगा कि इन सबको, उसके बाद मुझे काम करना है कि उन सबको कंसेक्यूटिव सम को मिनिमाइज करना है, जो कि एक बहुत ही कॉमन और सिंपल प्रीफिक्स सम की प्रॉब्लम है. एंड या लेट मी शो यू द कोड इटसेल्फ, उससे थोड़ा ज़्यादा समझ में आएगा, ठीक है? तो पहले मैंने एक मैट्रिक्स डिक्लेयर करी है, उसमें मैंने इनपुट लिया है, ठीक है? स्टैंडर्ड लॉरम एप्सम. उसके बाद मैंने एक आंसर वेरिएबल डिक्लेयर किया है जिसमें मैं एक्चुअली आंसर स्टोर कर रहा हूँ, that what is the answer that I get if I form a bridge on this particular row. All right, and ठीक है, and this is n plus 1 because it is possible to make n bridges in total. I have just taken an n extra n for no reason. Now I move forward and I create a dp. Now dp of 0 is equals to 1 because अगर मैं जीरो वैल्यू पे हूँ तो भी मुझे एक सपोर्ट तो चाहिए ना, ताकि मैं यहाँ ब्रिज बना सकूँ. बिकॉज क्वेश्चन में स्टेटेड है कि जीरो कुछ भी अगर वैल्यू है ए आई जे, तो ब्रिज बनाने की कॉस्ट होगी ए आई जे प्लस 1, ठीक है? क्योंकि एक इतनी हाइट का ब्रिज तुम्हें चाहिए होगा. ओके, ऑल्सो अगर तुम लोग को समझ में ना आ रहा हो तो मैं तुम्हें समझाता हूँ. अगर ब्रिज हमेशा स्ट्रेट लाइन में बनेगा ऐसा, तो अगर जीरो है तो यहाँ पे, टू है तो मतलब ये पॉइंट से यहाँ तक का ब्रिज स्टैंड होगा, फिर इतना, फिर इतना, और मान लो कि कुछ में इतना, लेकिन हाइट सेम रहेगी कि ग्राउंड ऐसा कुछ है। ठीक है, समझ रहे? ओके। आई थिंक विजुलाइज करने में अब थोड़ा मदद मिल रही होगी कि हमें करना क्या है। ठीक है, अब मैंने क्या किया कि सेट में मैंने वन डाल दिया, जैसे कि यहाँ पे था ना 1 2 3 4 5 0 0। तो सेट मैंने वन डाल दी क्योंकि यहाँ पर मैं सोच रहा हूँ कि अगर मैं ब्रिज बना सकता हूँ। ठीक है, तो मैंने यहाँ ब्रिज बना लिया। ओके, देन आई मूव फॉरवर्ड। तो अब डी पी ऑफ जे इसका मतलब कि वन, मान लेते हैं कि डी की वैल्यू है टू। ठीक है, तो मैं यहाँ पे आया, अब मैं देखा कि डी पी ऑफ टू की वैल्यू कितनी हो जाएगी। मुझे यहाँ पे ब्रिज बनाना ज़रूरी नहीं है क्योंकि मैंने ऑलरेडी यहाँ पे ब्रिज बना लिया है। तो डी पी ऑफ वन हो जाएगा, जो फर्स्ट एलिमेंट प्रेजेंट है विच इज़ वन, उसके बाद में इसकी वैल्यू प्लस वन, सो दिस इज टू, दिस इज थ्री, सो दिस इज वन, दिस इज थ्री, एंड देन आई मूव फॉरवर्ड। अब सेट का साइज ग्रेटर देन टू हो चुका है, तो मुझे इसको रिमूव करना पड़ेगा। इसकी वैल्यू टू की वैल्यू जाएगी टू प्लस थ्री प्लस वन, सो दिस इज सिक्स। dp of j actually tells me the cost of making the minimum cost of making a bridge up till this element. All right, up till this element what is the cost? Cool. And then I will just keep on repeating this for all these values which I have done here. So s dot begin plus 1 plus 0 5 comma g, and then insert this value into the set. Now this means that basically this is just another way of saying that now my set the size has exceeded d minus 1. So each time I will remove the first element, erase the first element, and then I have to erase the first element now, and then store it in answer. Okay, now I needed a prefix sum of all these values, which I have done by this. Yeah, this is simple prefix sum of all the values. This prefix sum actually denotes what is the cost of making a bridge up till this far. Like, let's say I'm in 0 1 2 3, these are the roads. So what is the cost of making a bridge here, and cost of making a row here plus here, cost of making a row here plus here plus here. All right, now we create a prefix sum, and now basically this is an algorithm which helps me find the minimum of k consecutive elements. All right, and yeah, that's it. Cool. So yeah, anyway, I would just want to say thanks to Priyansh Agarwal. His sheet has helped me a lot. I can now think the problems in a very quiet and clear fashion and come up with the solutions. It has helped my problem solving skills a lot. And tomorrow I will be live streaming Code Chef.